Hello YouTube. We just purchased this RZT50 Cub Cadet Zero Turn. It's a 2012 model. I bought it from the guy who bought it new from a local Cub Cadet dealer, and he only used it to cut his 2-acre lot or so for those few years. So it only has 160 hours on it, which isn't very much. And I bought it with the understanding that it does actually have a charging system problem. So it runs, you just have to charge the battery up almost like a toy car or something. When you use it, you have to charge everything up and get it, so it can start back again. So I don't know exactly what the problem is yet, but we're gonna dive in and see if we can figure out what's going on. So let's check it out. First thing we're gonna check is the battery voltage. The reason we're gonna do that is to make sure we have enough to kind of get the motor started. So we're just gonna probe right here. We got 12.67 volts, and so that's a good start. We can check this fuse here too. This fuse looks like it's okay, but we're just gonna pull it out, check that. So it looks good, but we're just gonna go ahead and check it with our meter while we're here. So that's good. So that's a fuse for the charging system. We're also going to check all the way back here at this voltage regulator. There's a voltage regulator bolted to the side of the engine. That has the alternator or stator connected to it there, and then this red wire actually just goes to the battery. Actually goes to the ignition switch and then to the battery. So we're just going to check for voltage right here on this wire to ground. So let's check voltage here. So this is the red wire to ground of the battery, 12.67. so we're good there. Well, it looks like it doesn't go through the switch because I have it turned off right now, so we're good. So let's do a basic check of the alternator. Alternators put out AC voltage, and this voltage regulator is a rectifier also, which makes the alternating voltage into a DC voltage. So what we're going to have to do is start the engine, and then we'll probe this connector in AC right here. So we're going to put it in this setting right here, the volts with the AC signal, the little squiggly line. So we're going to put our meter into here, and right now we have nothing, but let's start it up. Let's see what happens here. So is everybody good? Alright, the voltage should increase as the RPM increases, so let's try that out. I would say our alternator is working fine. So now what we're going to do is check. We'll plug that back in. We're going to check our output from the voltage regulator with the engine running and the alternator connected. So let's check the battery voltage one more time, and it should be about the same. Got to put it on DC there. Should be about the same as what's coming out if the voltage regulator is bad. Well, looks like there's no voltage output. So One more thing to check with voltage regulators is they're dependent upon a ground. They need, or at least this one is, it looks like it's bolted to some type of plastic housing. And Kawasaki decided to put a ground strap between the bolt that holds it on and the frame of the engine. So let's check from the ground. Let's put this in ohms. Let's check from the ground of this frame of this voltage regulator to the ground of the battery. Well, we have 9 ohms. Let's check from the engine frame to the ground of the battery. Okay, 0.6. That looks a lot better. So that could be an issue. Let's investigate the ground wire. Where is that? Oh, here it is, right here. So get around here so you can see. So here's the ground wire that goes to the engine block, and it's right there. And then this ground wire here, down here, oh, look at that, it's loose right there. I wonder if that's the problem. Huh. Well, let's make sure it isn't dirty or whatever in here, and maybe we'll just tighten it on up. Let's see if it's got any corrosion. Well, it looks clean. Well, that's all dirty looking. Maybe we'll flip that around like that, so the clean part is toward the aluminum. Let's get a little sandpaper and polish everything up, and we'll check it in a little bit. I found this brush in the tool shed there. I don't have a whole lot of my tools with me, but we're gonna try to polish up that connector right there, or the bolt hole where that ring terminal attaches. It looks to be just aluminum, so I don't think it's going to take a whole lot to get it cleaned up. Let's check this too while we're here. Looks like it's coming clean. Let's try that. As you can see, there's plenty of room to work in here. Well, I'm gonna have to get a screwdriver on a ratchet or something. Let's see what kind of tools we got. What I found was this. I've got an adapter that goes from 3/8 to quarter, and then another adapter that goes from quarter to screwdriver bit kind of holder. So let's see if it works here. Let's tighten this thing down. Doesn't look like it's tightening down at all because it just goes into a plastic housing. I'm gonna say that's probably the problem, so we might have to do a little something different with this. Yeah, it's not tightening down at all. Let's say that's not good. Alright, let's reevaluate. So since we had some trouble with the screw tightening down on there, this is just to prove, to see if the voltage regulator is still okay, or if it actually has failed and it was just a resistance problem between this ring terminal and the housing of the voltage regulator. So I've got this jumper here. So let's get this clamped onto the housing of the voltage regulator. Kind of wiggle it on there a little bit, and then we're going to clamp it onto the wire right there like that. Let's see, let's check and see if if everything works now. Let's see what we got. Okay, it looks like it's working. We're going to prove a point. Well, let's unhook this and leave the ground open to the voltage regulator rectifier, and let's start it up again and see if the voltage does not change while we increase throttle. Okay, it looks like that's the problem. That this wire and the housing of the voltage regulator were not making a connection. So I'm going to probably re-engineer what Kawasaki did to get this voltage regulator grounded. So I don't know what I'm going to do yet, but I'm going to first take the voltage regulator off of the housing, the plastic housing that's there, and maybe just throw a bolt through it or something, and let's see if we can do that. So, let's go ahead and let's take this out completely from the engine. Let's see what we're working with here. It's got some gunk built up in there. Go ahead and clean that out. Alright. Well, it looks like this is where the problem was, and you can kind of see where that aluminum housing was getting arced on by that ring terminal. So if we put that in there with a bolt, a through bolt and a nut, and hook everything back up, it would work just fine, whether it was bolted to this little plastic housing or not. So I think that's what we're going to try to do. Alright, well, I got done modifying and re-engineering, and it was very simple what I did. So let's take a look. This voltage regulator now has a bolt and a lock washer and a nut. This is all stainless. And then I just stuck the ring terminal underneath of there and tightened all that down and put one bolt back in there. We'll see if it holds up. If I need to do something different another day, well, that's what I'll do. But for now, today, it's the middle of grass cutting season, so we're just going to hook everything back up here the way we found it. There's the battery, here's the voltage, or the alternator. So I haven't even started it up yet. Let's start it up and try it out and make sure everything works. Right, that is good news. That'll save us about $40 for a new voltage regulator. So that's excellent. So we got it running. That's amazing. So next we're going to change the oil in here and the oil filter, and we're going to take all the blades off and sharpen them up. So yeah. Thanks for watching, guys. We'll try to keep some cool stuff like this going, and see you next time.